The James Webb Space Telescope has done it again. It has found a galaxy so old that it's beginning to rewrite the rules of the universe, and this discovery is about to change everything we know. To understand why, we rewind to 2022 when the farthest known galaxy, GNZ 11, was spotted by the Hubble Space Telescope, a landmark discovery that pushed the limits of Hubble's 2.4-meter mirror. But Hubble had its limits. Then came JWST with its massive 6.5-meter mirror, perfectly tuned to infrared, the ancient stretched light from the early universe. JWST didn't just continue Hubble's mission. It smashed its records by finding JADE's GSZ14-0 with a redshift of 14.32, and then MOMZ14 with an even higher redshift of 14.44, pushing our view deeper into time. What stunned scientists wasn't just the distance. It was the nature of MOMZ14 itself. This tiny galaxy, only 500 light-years wide compared to our Milky Way's 100,000, was incredibly bright and full of newborn stars, when galaxies from that era should have been faint and barely detectable. Even stranger, it showed no sign of a supermassive black hole, unlike most galaxies we know that grow and evolve around one. JWST spectrograph revealed that MOMZ14 was unusually rich in nitrogen, a chemical signature similar to some of the oldest star clusters orbiting the Milky Way, hinting that multiple generations of stars had already lived and died before MOMZ14. This means galaxy evolution might have started much earlier than we believed, raising the big question, how many more galaxies like MOMZ14 are out there? Before JWST, we thought such galaxies were extremely rare, but now they're popping up everywhere in its surveys, known as the little red dots. And scientists believe MOMZ14's record might soon be broken. The more we look, the more we find, and each discovery forces us to question our assumptions. MOMZ14 doesn't fit our current models that suggest early galaxies should be rare, slow-growing, and chemically simple. It's none of those things. It's fast, bright, complex, and it shows our models are incomplete. The early universe was far more active than we thought. And this is just the beginning. The upcoming Nancy Grace Roman Space Telescope will join JWST, covering much larger areas of the sky in incredible detail, possibly uncovering hundreds or thousands more galaxies like MOMZ14, each one a time capsule from a universe we're only starting to understand. But for now, MOMZ14 is a milestone, a flicker of light from a time when the universe was still finding its footing. And as JWST's findings pile up, the universe keeps defying expectations. Some scientists now propose something even more radical, that our entire universe might exist inside a black hole. Recent research found that most galaxies seem to be rotating in the same direction, which shouldn't happen in a random universe where rotations should be evenly split. This surprising alignment contradicts existing cosmological models and may point to the idea that our universe is the interior of a black hole within a larger parent universe. When matter collapses into a black hole, it forms an event horizon, beyond which nothing escapes, and what happens inside remains a mystery. The theory of black hole cosmology, also called Schwarzschild cosmology, suggests that the Big Bang wasn't an explosion in empty space, but the moment matter collapsed into a black hole, creating our universe inside it. This idea implies that every black hole could be the gateway to another baby universe, possibly explaining why the constants of nature seem perfectly fine-tuned for life, as stable universes may be more likely to survive and reproduce in this process. Black holes also contain immense entropy, corresponding to the vast information within our universe. Some extended theories of general relativity, like Einstein-Cartan relativity, introduce torsion, the twisting of spacetime, which could create repulsive forces at high densities, preventing singularities and possibly triggering a big bounce, where the core rebounds and expands, giving birth to a new universe. This bounce could explain our expanding universe, not as something from nothing, but as a rebirth from within a black hole. This theory suggests an ongoing, self-replicating. Some cosmic structures also appear to be aligned, indicating the universe might have a preferred axis, challenging the belief that the universe is isotropic and homogeneous. This could point to unknown physics tied to how our universe formed or how fundamental forces interact on the largest scales. Regardless, the universe is proving to be far stranger than we ever imagined, and uneven galactic rotations will likely push astrophysicists to rethink parts of our fundamental understanding of the cosmos. What do you guys think? Let me know by dropping your comments below, and as always, Don't forget to subscribe to Territory, because this is your space.